Use continuity tests to determine continuity at a point. We have the function at x equals 2. Let's find the limit as x approaches 2 of f of x. And when we find limits, we first try to plug in the value and see if there's any problems. And in this case, there aren't going to be any problems with just plugging in the value. We have 4 plus 6 minus 1, that's 10 minus 1. The value is 9, so the limit's 9. And then we want to find the function value. F of 2 is equal to, well, we do the same thing. We have 2 squared plus 6 minus 1. That is also going to be 9. Then we make the statement that the limit as x approaches 2 of f of x is the same as f of x, as f of 2, I should say. And that is the definition of continuity. So continuous, the function is continuous at x equals 2. Let's look at a piecewise function. We're looking at the interesting spot is at 1. So let's find the function value. F of 1 is equal to 1 squared, which is 1. And now we want to find the limit as x approaches 1 of f of x. Well, this point right here, the point at 1 on x plus 3 is the point 1, 4. And the point on x squared at 1 is 1, 1. And 4 and 1 are not the same. So these two branches of the piecewise function are not joining at x equals 1. So the function, or excuse me, the limit does not exist. And since 1 does not exist, we say that we have a jump discontinuity. A jump discontinuity at x equals 1. Use the calculator to determine intervals where the function is increasing and decreasing, and then we'll find all the local extrema. So let's go to the calculator. We'll turn it on. Y equals, we have x to the third minus 2x and then plus 2. And let's graph this. And we can see the function is increasing, then decreasing, and then increasing. We need to find the local extrema in order to get the increasing and decreasing. So let's go to calculate. Let's find the local maximum. They want the left bound, so the left side, then the right side, and then we'll take a guess that it's about right there. And we have an x value of, let's see, we have a local maximum of, the y value is 3.089, and that is happening at x equals negative 0.816. Let's get the local minimum. We'll go to second calculate. We have a minimum, and here's left, here's right side, and then we're going to go back and guess about right there. This is going to be a local minimum of, let's see what the y value is, 0.911 at x equals 0.816. And now we can say that we have the function is increasing on negative infinity to this x value right here, which is the negative 0.861 or 816. And then it's increasing again from 0.816 to infinity. Then this function is decreasing as we go left to right on negative 0.816 to 0.816. Find average rate of change for this function on 1 to 4. We need f of 4 minus f of 1 all over 4 minus 1. This is average rate of change. Let's plug 4 in. We get 16 minus 4 plus 1, and then minus f of 1, which is 1 minus 1 plus 1. And that's all over 3. So we have 12 plus 1, that's 13, minus 1, that's 12 over 3. So the average rate of change is 4. End behavior of polynomials. Let's talk about if we have a positive even. So if we had plus 3x to the fourth, it's going to look a lot like the positive x squared. So this is the positive and even. Here we have negative and even. So negative and even. That would be like negative 3x to the fourth. We could talk about positive odd. For example, if the polynomial started out with positive 6x to the seventh, where the exponent is odd, the function is going to look like an x to the third, a positive x to the third. So it's going to look like that. And then if we have a negative odd, for example, if we had negative 6x to the seventh, then the function is going to end like this. There might be some twisting and turning in the middle, but eventually that's how it's going to have to end. Find the end behavior of y equals negative x to the seventh minus 3x to the third minus 5x. Well, for end behavior, we only need the leading term. And so we say that the limit as x approaches infinity of f of x is equal to negative infinity. This one is going down. And then the limit as x approaches negative infinity, as this function goes to the left, the y values are going off to infinity. So we say if f of x is equal to infinity. Divide using synthetic division. Here we have this polynomial divided by x minus 2. So we're going to plug 2 into the box. We plug into the box what makes this 0. And then we have 2, negative 1, 2, and 1. And with synthetic division, we just bring the first one down and then multiply and add. So 2 times 2 is 4, negative 1 plus 4 is 3. 2 times 3 is 6, 6 plus 2 is 8. 2 times 8 is 16, and the remainder is 17. So we have 2x squared plus 3x plus 8, and then plus 17 over x minus 2. On this problem, we're asked to solve this inequality. Let's factor. We have x plus 3 times x minus 1 is less than 0. And so the zeros are negative 3 and 1. So we can put this on a number line. We have negative 3 and 1. So those are the points we're looking at. And they actually have to be open dots because we don't want to include what makes this equal to 0. Let's check negative 4. We can check 0. And we can check 2. So when we plug negative 4 in, we get negative times a negative, which is a positive. When we plug 0 in, we get positive times a negative, which is negative. And when we plug 2 in, we get a positive times a positive, which is positive. So this function is less than 0 in between negative 3 and 1. So the solution is negative 3 to 1.